I'm Irfan Shah Sheikh and I'm a PhD student at Aarhus University. Um, so in this series of videos, I'm going to discuss about computability. So the computability um, is a subtopic of computability and logic, which is an undergraduate course at Aarhus University and currently taught by Professor Jacob van de Paul. So he is my supervisor and I was a teaching assistant for this computability and logic course. So in this video I'm going to summarize what I'm going to discuss in upcoming videos and what to expect and what not to expect. So before going into the summary of these videos, let us think about what is computability. So why do we need to study it? Before going into the broad topic computability, let me ask you a specific question. For example, you are running a program in your laptop and what are the two main concerns that you have? At least for me, the first concern will be, okay, how much time it's going to take, other than whether it will give a correct answer or not. Will it run for 1 hour, 2 hours, or 1 year? So, and the second concern for me is my RAM enough? Is my memory sufficient? So this is even so time and space are general characteristics of any problem. So whenever you are thinking about a problem, you want to know how much time it would take, you want to know how much space it would take. So computability is a branch where you look at mathematical models, where the mathematical models such as languages, Turing machines, etc. And you take these models, you model some problems, and you think, you analyze about how much time would this problem take, how much space this problem would take. So that is the core idea of computability. And then if there are, let us suppose there are two problems, problem 1 and problem 2, you want to know which one is relatively harder. So what we do in computability is that we generate some classes. Let's say all these problems will take polynomial time, all these problems will take polynomial space. So by doing so, if you ever encounter a new problem, if you know which class it falls under, let's say NP complete, then you approximately know how hard the problem is. So that is the idea in computability. And that's not the only thing. And if you go to the extreme in problems, let us suppose we have a computer which is the best computer. It has infinite time, it has infinite space, infinite computation. So now the question is, given some problem with this computer, can you solve it? That means if you have infinite time and space, infinite computation, can you solve that particular problem? It seems there are many problems, infinitely many problems, where you can't solve it, even if you have infinite time and space. So it is quite fascinating to think about the problems and group them and so understand why some problems are easy, why some problems are hard. Not that we know all the answers, but at least it is important to know the difference. It is important to know how to group them, how to place them in some particular class. So now coming to this series of videos of computability. So this follows the general pattern, the same pattern in the computability and logic course at Aarhus University. And we are going to use the textbook Introduction to Languages and Theory of Computation. So this is the book by John C. Martin, and so the main topics we are going to look at are finite automata. These are quite basic concepts: regular expressions, contextual languages, Turing machines, and many more. So what you can expect from these series of videos. I will try to provide some point of views which are easy to understand for these simple concepts and harder concepts that will come along the course. And what I might not provide you here is I might not give all the details that are possible, because even though these are simple concepts, there are many details, and but there are comprehensive courses that you can follow, MIT courses, and I will probably link some other courses that are much better if you want to know more details. But in this series of videos, I want to give you some pointers which will help you understand some difficult topics and some basic topics. So that is the main takeaway that you can take from these videos. Okay, I hope this one will be useful for your studies, whether you are in Aarhus University or outside of Aarhus University. And as the series goes on, if you have any concerns, just let me know. If you think this is too broad, if you think this is too specific, or if you want me to cover some other topics, just let me know, and then we'll do something about it. Thank you. See you in the next video.